Hi guys, welcome to my Math and Physics Hub. In this video, I'm going to cover a math question which includes a lot of concepts. The first is inverse function. The second is composite function. And the third is transformation of function's graph. So I'm going to make 3 videos, and within each, I'm going to cover one of the sub-questions, as this big question has 3 sub-questions. So, all right, let's start with the first one. Alright, as long as this question has something like f to the power of -1 or g to the power of -1, we have to introduce a concept named as inverse function. So what is inverse function? Simply to say, inverse function is just write whatever in y into x and whatever in x into y. For example, you get a y equals to 7x, right? This is a function. So for its inverse function, is x equals to 7y. This is just its inverse function. It's quite simple, right? And you just write it into the normal way that we perhaps observe every day. Y to the left-hand side and x to the right-hand side. So the 7 becomes 1 over 7x. So this is the inverse function of this. Let's say fx equals to 7x, then its inverse function becomes 1 over 7x. So in graph, whatever, let's say this is y, this is x. So whatever in x and whatever in y here, wow, just observe. You can see that whatever in x becomes y, right? And whatever in y becomes x. It's just like a flip over in this way. So it's very easy to find out. They are symmetrical to this line, right? And this line is obviously y equals to x. So inverse function is symmetrical to its original function by this line. You can see that y equals to 7x is symmetrical to y equals to 1 over 7x by this line, right? Let's say you draw, this is a y equals to 7x, right? And this line, how to draw it? Well, you find when x equals to 7, y equals to 1. So it's like this, and you may find, wow, they're just symmetrical according to this line. Same thing, if let's say my original function is y equals to x to the power, e to the power of x, right? So its first function is x equals to e to the power of y. And in that way, we're going to write it as we shift y to left-hand side and x to right-hand side. We do logarithm for both sides, right? Log x and log x to the power of y. And to shift this y to in front, it becomes, which is just y. So y equals to ln x will be the inverse function of y equals to x to the power, e to the power of x, right? We know that this graph is, this is 1, right? It's like this somehow. And this is y equals to x. And this graph is like this. It's perfectly symmetrical to y equals to x. So that is inverse function. It's quite simple, right? You just write whatever in x into y and whatever in y into x. That's it. But there must be some criteria to support this function's existence. Let's say I got something like like this. Like this, right? And according to the law, we find its inverse function. It's y equals to x. And you can find out this function becomes something like this. right? It becomes like this. And is this a function? You have one x, but you have two y's value to be there. It's no longer a function. But so what to do? Does the inverse function of this graph exist? The answer is no. It doesn't exist, because if you get the inverse function of this, you can find it's no longer a function again. So there must be some restriction for inverse function. That is, before it is it has an inverse function, it must be a one-to-one function. So here I'm going to write one-to-one function. Well, just by observing, you see this graph? It has a decreasing and increasing. But when you flip it over here, the decreasing part will be this one, right? And this increasing part will be this one. So either decreasing or increasing itself, it has its inverse function. But when they combine together, then it doesn't exist. So one-to-one function means that within its domain, first you must in its domain. In this domain, there's only one tendency, either increasing or decreasing. Either increasing or decreasing. So by simplifying this sentence, I'm going to draw something. Let's have a look on this graph. The same thing here, right? We know that if only decrease or if only it's increasing, when I draw a horizontal line here or here or here, anywhere above this lowest point, it will have two intersections, right? But when it's just increasing, you don't know how to increase. When you draw any line over here, it only has one intersection. And decreasing will be the same thing. Sorry. Wow. Anywhere you only have one intersection. That's the way to make sure your function is one-to-one function. So let's go back to the question now. The question asks us whether gx inverse function exists or not. First, we need to show whether it exists or not. The second is, if it exists, what it is. So the most obvious way is to draw the graph. We know g is a parabolic, so we're going to draw it out. Right? We know this lowest point with x equals to negative b over 2a, right? And a is this one, so it's 2 here, and b is negative 4, so it's negative 4 here. It becomes 2, right? And there we got a g2. We need to know the value in g, so g2 equals to 2 squared minus 4 times 2 plus 6, right? So this is 2. So this point will be 2, 2, right? However, in this case, x must be less or equal than 2, which means only this part. So draw it out. I said this is 2 and this is 2, right? So something like this. So let's say when you solve this question, when you find whether inverse function exists, we need to define whether gx is a one-to-one function. By the methods we introduced above, we draw horizontal lines there, right? So we can draw here. There's no intersection. It doesn't matter, because sometimes it doesn't say that the y always has a value to be respective to x. So here you get no value. Here you get only 1, right? Here you get only 1, right? Here you get only 1. And whatever above, it would always get 1 value accordingly. So we say that cos when x is x is less or equal to 2 and x belongs to real number, a line y equals to k has at most 1 intersection to gx where k belongs to real number, right? At most 1, right? Here you get nothing, so it's 0, but here's only 1. There's nowhere you get 2 intersections. So we say gx is 1 to 1. As long as it's 1 to 1, this inverse function exists, right? So we can solve with the first part. So the second part asks for what g's inverse exactly is, right? So we need to, to write exactly the thing into it. So we write gx into its inverse form. Let's say let y equals to this gx, then its inverse form is x equals to y squared minus 4x plus 6, right? We got that thing. And we need to do is to simplify. So how to simplify? We know that there is a equation you have learned before. It's a squared. It's a minus b squared equals to a minus 2ab plus b squared, right? So in this case, this is y. Your y squared minus 4y will be a squared minus 2ab. A is y. So a is y here, and 2 is within this 4. So b is just 2, right? 2 times 2 is 4. So it's 2 squared. And you plus 2 squared, you must minus 2 squared, and plus 6 equals to x. So you got a minus b, which is y minus 2 squared, and plus, this is a minus b squared. So what's remaining is 6 minus 2 squared, which means 2, right? So here's positive 2, and I shift it to right hand side, it's x minus 2, right? Then you have y minus 2 equals to, well, positive or negative, you don't know, x minus 2, right? You shift, and you shift this 2 over there. You got y equals to 2 plus minus x minus 2, right? But we know that on the graph, we know that this point is 2, 2, right? Whatever y here must be equal or greater than 2. So, can it be minus? Nope. It can only be plus. So, y is just 2 plus x minus 2. So this will be the result. And you have to write the domain out. In this case, x is less or equal than 2. So we can solve this question. Hey guys, we're done with the solution. If you have any questions to discuss with me, or you want to share some idea, you can just leave me a message or just comment under the video. Hope you guys like my video. If you like it, please subscribe my channel. See you guys in the next video.